As part of an instrument arrival procedure, a shuttle may be prescribed at the IAF, where to achieve the specific altitude at the final approach fix or final approach point would require excessive rates of descent from the minimum altitude at the end of the approach. The shuttle is therefore part of the arrival procedure of climbing or descending in a holding pattern. There are 5 standard segments of an instrument approach procedure. The following diagram illustrates these. Arrival routes are published where necessary, or where an operational advantage is obtained. The route will normally end at the IAF. Omnidirectional or sector arrivals can be provided, taking into account minimum sector altitudes. When cleared to leave the ATS route or airway, control will be transferred to the approach controller at the destination aerodrome, and the aeroplane will be cleared to the facility at a specified level. The aeroplane flies to the IAF, and with the approach plate to hand, the pilot will report. In the initial approach segment, the aeroplane has left the en route structure and is manoeuvring to enter the intermediate approach segment. The aeroplane approach, speed and configuration will depend on the distance from the aerodrome and descent required. Normal track guidance is provided along the initial approach segment to the IF, with a maximum intercept angle of 90 degrees for a precision approach and 120 degrees for a non-precision approach. If a course reversal is required, it is usually accomplished during this segment. There will be no intermediate fix as such, but the aircraft will be considered to be on an intermediate approach when it has completed the reversal manoeuvre and is inbound to the final approach fix or point. The intermediate approach segment is where the aeroplane's speed and configuration should be adjusted to prepare the aeroplane for the final approach. For this reason, the descent gradient is kept as low as possible, and the obstacle clearance requirement reduces from 984 feet to 492 feet in the primary area, reducing to 0 at the outer edges of the secondary area. The aeroplane is then flown with increasing accuracy to the FAF along the intermediate approach track. If there is no FAF, this leg is considered to be the final approach segment, and 90 metres of obstruction clearance must be guaranteed as the aircraft descends to MDA or H, which we will look at in more detail later on. For a precision approach, the intermediate approach segment will allow descent to an altitude such that the glide path can be intercepted from below. This avoids any false glide path problem. Where the intermediate approach segment intersects the glide path, it is called the final approach point, FAP, and is a point in space rather than a fix. Often, however, the outer marker will be heard around about this time. This is the segment in which alignment and descent for landing are made. A final approach may be made to any runway for a straight-in approach and landing, or to an aerodrome for a visual manoeuvre. Don't forget that 2 types of approach can be made, the non-precision approach and the precision approach. The non-precision approach with final approach fix has a segment that begins at a facility or fix, the FAF, and ends at the missed approach point, MAPT. The FAF is positioned on the final approach track at a distance that permits configuration and descent from the intermediate height to the MDA or H for a straight-in landing or circling. The optimum distance of the FAF from the threshold is 5 nautical miles, the maximum distance being 10 nautical miles. the FAF is crossed at or above the specified altitude and the descent initiated. A step-down fix may be incorporated, in which case 2 OCA or H values will be published. For a VOR or DME approach, several types of fixes may be depicted, each with its own crossing altitude. The non-precision approach without final approach fix exists when an aerodrome is served by just a single facility located on or near the aerodrome and has no other suitable facility designed to form an FAF. A procedure is designed where the facility is both the IAF and the MAPT. The procedure will include a minimum altitude or height for a reversal procedure or a racetrack. In the absence of an FAF, descent to MDA or H is made once the aeroplane is established inbound on the final approach track. Descent to MDA or H may be made immediately, if there is no step down. However, particularly for large aeroplanes, a continuous descent final approach, CDFA, would be preferred. The CDFA treats a non-precision approach as if vertical guidance were available. A 3-degree glide path is constructed from a point 15 meters or 50 feet above the runway threshold back to the final approach fix. This descent path is followed until a decision to abandon or continue the approach is made sufficiently above the MDA or H, so as not to jeopardize obstruction clearance should a go-around be the decision. Research has shown the non-precision approaches carry an increased risk of controlled flight into terrain, CFIT. The CDFA allows constant supervision of speed, power, configuration, descent path and height, an ideal situation for managing the final stages of approach of an airliner and thereby avoiding CFIT. Until standalone GNSS precision approaches are fully developed, a precision approach will probably mean an ILS approach, and in this instance the final approach segment begins at the FAP. You should recall that this is the point in space on the centre line of the localizer specified for the final approach track, where the intermediate approach altitude or height intersects the nominal glide path. The width of the ILS final approach area is much narrower than those of non-precision approaches, and descent must never be initiated until the aeroplane is within the tracking tolerance of the ILS localizer. The ILS Obstacle Assessment Surface, OAS, assumes that the pilot does not normally deviate from the centre line by more than half-scale needle deflection after becoming established on track. In the event of loss of glide path during the final approach on an ILS precision approach, the approach will become a non-precision approach and have to use the OCA or H published for a glide path in operative circumstance. In any event, the final approach segment ends either at touchdown or at the missed approach initiation point, if a missed approach is flown. When determining the decision height for an ILS approach, the obstacles in the approach path and missed approach areas, along with the constraints of the ILS installation, are considered. The calculated OCA or H is the height of the highest approach obstacle, or equivalent missed approach obstacle, plus an aeroplane category related allowance. The OCA or H is published on the plate for the categories of aeroplane for which the approach procedure is designed. The values assume the following as standard. Cat 1 is flown with a pressure altimeter. Cat 2 is flown with a radio altimeter and flight director. Wingspan is not more than 60 meters, and the vertical distance between wheels and glide path is no more than 6 meters. Missed approach climb gradient is 2.5%, and the glide path angle is a minimum of 2.5%, has an optimum of 3%, and a maximum of 3.5%.